All right, so we've got 4 different equations here. They all look pretty similar, but we've got to be careful and make sure we read these problems so we know what type of problem we are solving here. So our first one, $4,000 deposited, 3 years, 2.8% simple interest. That is our important clue here. Simple interest tells us we are using our simple interest formula. That one is always nice and obvious for us. It'll say simple interest. The challenge with simple interest is remembering that that formula only gives us interest earned. It does not give us the ending balance. And so we do have to do a little bit of extra work here at the end in order to get the ending balance. And so my interest earned on the simple interest account is going to be $336. And so when I add that to my principal, that means that in 3 years, we would have $4,336. The $4,000 we started with, and then the $336 that we earned in interest. And our second one up at the top right, this one has a very important phrase to it as well. Compounded continuously. That's an infinite number of calculations. And that one is our equation that uses our exponential base, our E. And so again, when we see compounded continuously, that is our big clue to use that special E formula, PERT. So 4,000 E to the 0.028 times 3. And this one is nice enough to give us the ending balance. Just be careful, make sure you are including your parentheses and it is in the exponent, especially if you're typing in with Desmos, and this would round up to 52 cents. So these are my 2 obvious ones. If you see those 2 phrases, you should automatically know those are the specific formulas that you use. For our next 2 here, these 2, they look super similar, and it does require you to think a little bit outside the box. And maybe not so much think outside the box, but just read and think carefully. And so we see these 2 are very similar problems, but there's one difference here. This one is just 4,000 deposited into an account, where our second one is 4,000 deposited every month. Both of them are compounded monthly, but when we deposit every month, that is our periodic deposit. And when we just deposit one time, like we do on the left-hand side here, this one is just our compound interest. And so that is our clue to tell us which equation we're going to use. So again, one single deposit is just a compound interest formula, like so. And so I'm going to plug that in. And again, N is 12 because it is compounded monthly, or 12 times a year. 43.50, and that does round up to, to 9 cents. And then over here for periodic deposit, a little bit more complicated looking of a formula. This one, you've got to be super careful that you've got all of the required parentheses in there and you don't miss anything when you are writing it out and also when you are typing it in. And I always suggest that you write it out on paper first and then type it into your calculator once you have written it out. It's very easy to make a mistake when typing it in, even when you write it out, but you are less likely to make those mistakes if you write it out first and double check that you've included all of the required parentheses for this problem. And then I'm just going to take a minute to carefully type this in. And we end up with $150,038.53 because we were putting $4,000 every month on top of interest earned. So it's a lot more money that we get there because we are constantly adding money to our account, allowing us to save a lot more and even earn a lot more in interest.